So here we go. We're going to venture off into chapter 4. Chapter 4 is over exponents and logarithms, which I know is everyone's favorite. But we'll get by. So here we go. Your first problem here, number 1. There's only 7 in this section, so hopefully we don't drone on for these videos forever. But anyway, it has 4 parts to it. We're supposed to graph the function y equals 2 to the x. So again, this chapter is over exponential functions. This is classified as an exponential function because my variable x is located in the exponent, hence the exponential name to it. So again, we're going to make this via a t-chart if we wanted to, just understanding we can use different powers of x. So we're going to go with -2, -1, 0, 1, and 2, just because that's going to center me around where I need to go, and we're going to make a graph of this function. Okay, so this is going to be in reality. This is going to be 2 to the -2nd power. We're going to have to go back and remember what negative exponents cause. That causes reciprocation. So 2 squared is 4, but we're going to reciprocate that, so that's at 1/4. So at -2, it's going to have a value of 1/4. If we go with -1, 2 to the -1st power, so all that's going to do is flip it over, so that's going to be 1/2. Okay, I need to put this on a different screen because I can't see what this looks like, so sorry. Okay. And then, sorry, we got at -1, it has a value of 1/2. So the next one, we're going to have 2 to the 0 power. Anything to the 0 power is 1. So we're looking at that. 2 to the 1st power is just going to give me a 2. So at 1, it's going to have a value of 2. And we can see it's growing exponentially. Okay. As far as when we go 2 squared, that's going to give me 4. So at 2, it's going to be up here at 1, 2, 3, and 4. Okay, so it grew from 1/4 to 1/2, so it grew by 1/4, then it grew by 1/2, and then it grew by 1, and then it grew by 2, and then our next one would be 2 to the 3rd, which would be 8, it grew by 4. So we can see it's kind of doubling each time, which is exactly what it should do. An exponential function is going to look like that. So that is my base function, y equals 2 to the x, which is what we're supposed to graph off the top. Okay, I got to rearrange my screens for a second here. Hopefully, if this works, it didn't work. Okay, let's try again. If we click on that, again, you're going to have to use your exponential tool, and I believe you just have to plot points in that. So the next part of that is going to be, it wants you to graph a function. It wants us to graph y equals 2 to the x minus 2, and then its asymptote. And then graph the asymptote as a dashed line. Use the graph tool of the function. So I don't know what all these parts are. So bear with me. I'm going to drop my exponent tool in here real fast, just so we can. Oh, okay. So really, there's nothing. It's going to be one where we're going to shift and change it. Okay. So it's not asking me to do what we did here. It's not asking me to plot points. It is just asking me to give the basic function. So we can just go ahead and hit check answer, and we'll see. Oops, didn't like that. Use the transformation of, okay, I guess if I would read, that would be helpful. All right, so here's what we're going to talk about. I'm going to go ahead and graph this first one, just so we have an idea of what's happening. So, again, we're going to go with x and y. We'll use the same exact points, although that's going to leave me with not a whole lot of room to spare, but we're going to hopefully see what happens here, okay? So, again, we have 2. In this case, we're going to have -2 minus 2. So now we have 2 to the -4th. And 2 to the 4th power is 16, so this is -1/16. Okay, so that got really, really small. Okay, when we have negative, and I didn't leave myself room at all, but -1, 2 to the -1 minus 2, which is going to give me 2 to the -3rd, which is going to be 1/8. I don't know why I put a 1 negative here. I screwed that up. I'm sorry. It's just going to be 1/16. Okay. Oh man, I'm trying to squeeze this in and not paying attention to how big I'm writing stuff. 2 to the 0 minus 2. Well, that would be 2 to the -2nd power, which is going to give me 1/4. So we'll slip that in here. It's 1/4. 1. 2 to the 1 minus 2, which is going to be 2 to the -1st, which is going to be 1/2. And then, so what I need to do is we need to extend this to 3 and 4, just so we have an idea. So what is happening here is each of these points is, let's finish this up. I'm sorry, I'm very disjointed tonight. 2 to the 2 minus 2, which is going to be 2 to the 0, which is going to be 1, which we've already known. We already did that. 2 to the 3 minus 2, which is 2 to the first, which is going to give me a 2. Okay, so we can see instead of being at 1, 2, this thing is at 3, 2. Otherwise, it's the same exact point. So what happens is really this thing gets shifted. Every point here gets shifted to the right by 2 units. And so we look here, and we can see that we can, when we have a variable, a shift in the exponent, okay, that is going to cause a horizontal shift, okay? And it's going to give, again, what causes that 0? A positive 2 causes a 0, so this is going to go right 2, okay? So right 2 units. And when you look at your, what you have to do, we have a vertical shift and a horizontal shift. So this had a horizontal shift of 2 units. So now we'll check that answer. Oh, and we have to graph the asymptote. So do make sure one of the things that can get to be a pain in the bottom is you forgetting to graph your asymptote. And you can't really see my line that I'm putting here. I don't know if you can hear my clicks, but we have a horizontal asymptote here. It's that line that it never touches, and so that horizontal asymptote is going to roll in here at y equals 0, okay? And when it rolls in there at y equals 0, I actually can't even say, maybe you can see what I'm doing. I'm struggling tonight. The struggle is real. Anyway, this is always going to stay at y equals 0 unless we have a vertical shift up and down, and that vertical shift is going to be if we put something after the function, okay? And we'll probably get to one of those here in just a second, okay? But that's what we need to do. First of all, we had to go right to, and then we had make sure you plot the asymptote, okay? Because sometimes they're going to count us wrong, and we swear it's right, but in reality, I just forgot to do the asymptote, and making sure that your asymptote is a dashed line. For some reason, I can't get my line to stay dashed. There we go. Well done. All right, so then it asked me for the equation of the asymptote. So part B, the equation of the asymptote. My God, maybe I should just give up for tonight. So remember, I wrote that up here. It's y equals 0, okay? Y equals 0. What we have to be writing in there, okay? And actually, it already comes with the y equals, so all we have to do is drop in a 0. Fantastic, okay? And then lastly, we talking about the domain and range, all right? Those are the last 2 things we have to do for this one. So my domain, again, is all the values that I put in for x, okay? So if we drop that into interval notation as requested, we can see that this graph is going to go left forever and it goes right forever. So therefore, it is going to be negative infinity to positive infinity. Okay, so we're going to have a domain of all reals. So since I am doing this on my computer, we got to take some time for me to type this in there so I can see what the next question asked you is going to be. Okay, well done. The range of this. So again, we talk about the range. My graph does not exist down here. The graph only exists, in this case, above the x-axis. So it's going to go from 0 to infinity. So the range is going to go from 0 to positive infinity. And we'll take 5 seconds and hopefully drop that into an answer just so I can make sure we hit upon all the things that it's going to ask you for. All right, we've knocked out problem number 1, okay? That was it in a nutshell. Now we just have to figure out what are going to be the different nuances, okay? So that was, this was number 1. So next we have to talk about what does number 2 look like. So here we go, number 2. All right, use the transformation of y equals 5. So in this case, y equals 5 to the x power is going to be my base, okay? But what they're asking me to look at is y equals 5x minus 5. So now what we have to understand is This stayed, my base function stayed exactly the same. The only thing we threw on was this -5 after the function. And what we have to understand is this is going to be a vertical shift. So I'm going to, in the vertical shift area, put 5 down, or in this case, a -5. So we're going to put -5 in the vertical shift box. Okay? And then as well, we have to graph the asymptote. Okay? So again, if we go back to, if we went back to my original, the original is y equals 5 to the x power, so it is going to be an exponential function looks something like that again, except this one's going to get shifted down 5 units. So at 1, 2, 3, 4. Okay, so if it started here at 0, 1, it's going to be here, so it got shifted down 5 units. So instead of having a horizontal asymptote here at y equals 0, now I'm going to have a horizontal asymptote at y equals -5. So that is going to be, basically my vertical shift is going to be my y asymptote as well. And so that's y equals -5. I have to remember I'm going to graph, I have to graph my asymptote line as well. Okay, it is going to ask me again for the domain and the range. All right, my domain, for any exponential function, we can quit thinking about it. It's actually going to be all reals. I'll never have a domain restriction when it comes to an exponential. And then my range, and again, since this one got shifted down 5 units, we're going to drop it to -5, and now it's going to go up to infinity. Okay, so that horizontal shift is going to affect, the vertical shift is going to affect that range. Okay, and that's what we need to get out of that one. All right, move on to problem number 3, if I can get my screens on my computer set to the right spot. Okay, and 3, so now in 3, we're going to go with y equals 2 to the x plus 3 plus 6. Okay, so now when we're clicking on that function and we're filling in the box, this one's going to have a horizontal shift. And it's going to have a vertical shift. Okay. The horizontal shift comes from this guy right here. A -3 causes that to go to 0, so this is going to go 3 left. Okay. But we're not going to put we're not going to put 3 left in that little box. We're going to indicate the 3 left by putting a -3 there. Okay. The vertical shift comes from here. Okay. So remember, we'll put HS for the horizontal shift. We'll put a VS for the vertical shift. And the vertical shift from that, so we're going to go 6 up, but again, we're not going to put the up. It's just going to be a +6. So those are the 2 things we're going to do there. So we're going to talk, we just have to show how the shift is. We're going to have to plot an asymptote line. This got shifted up 6, so that means my asymptote is going to be at y equals 6. Okay? And yeah, that's going to take care of the first part. So my domain and my range. Okay, my domain again is going to be all reals. We're not affected. The exponential function doesn't have restrictions. This one got shifted up 6 units, so that means that 6 is going to be my lower boundary and infinity. Now, sometimes we have to pay attention to if we threw a negative sign in front of this. So if this was and again, I hate to put it there, so I'll do it here real fast. If there was a negative sign in front of it, we're going to scratch it out real fast because there wasn't. But that's going to cause things to flip over. So then my exponential function would actually look like this instead. Okay, if I did that. Okay. All right, that was 3. Let's check out 4. All right, what are we after in 4 here? We are going to graph y equals 8 to the -x. Okay, so we talked about earlier, if I graphed, if I put the negative sign in front. So if we put a negative sign here, this causes it to reflect over x-axis. Okay, if I put the negative sign in front. if we put the negative sign in front of my exponent, this is going to reflect across the y-axis. So let's take a look at that and talk about y, all right? I hate to use 8 because we're going to hit some astronomical numbers, so I'm going to change this for us. We just have to remember that in this particular case, we're going to hit this button, okay? It is just going to reflect across the y-axis. Let's talk about why it does for a second, and I'm going to jump back to y equals, actually we're going to go back to this problem here, and I'm going to real fast, if I had another colored pen, not that you could tell the difference between blue, I'm not sure you can tell anything on a video. I guess red is probably our best shot, so let's try red. Y equals 2 to the negative x, okay? Now that I have absolutely no space to write anything, we're going to steal it in right here, okay? And we're going to use the same exact ones, negative 2, negative 1, 0, 1, and 2. So we're talking about 2 to the negative negative 2, which is actually 2 squared, which is going to be 4. So this is 2 to the negative negative 1, which is actually 2 to the first, which is just 2. So now we can see my numbers are actually getting smaller, okay? 2 to the negative 0 power is actually going to be 1. This is going to be 2 to the negative first, so that's going to be 1/2. So we're seeing that we're actually coming through here at negative 1. It had a value of 2. At negative 2, it had this value up here at 4. And so we can see that this graph is coming through like that. Okay? So again, we have flipped it over the y-axis. All right, now we're all better people. Here we go. So we know that when we throw, get over there, when we have a negative sign, this is going to reflect it across the y-axis. If we stick it out front, that's going to flip it across the x-axis, which are 2 options. So we just need to make sure this checkbox, there's going to be a checkbox, will reflect across the y-axis. Then again, we have to graph an asymptote line, so don't forget to graph that asymptote line. It's going to be at y equals 0. Okay? And then we're after a domain again. Again, there's no restrictions here. Negative infinity to infinity are going to be as my domain, my range. And again, we're paying attention to the vertical shift. There is no vertical shift, so that means it's going to maintain itself at 0. Or you could look at your graph. That is up to you. Okay? All right, and the rest of this section is going to be, again, it's exponential functions, so we're going to have variables in the exponent. So we're going to start out with a formula that we just need to know. Again, our test is going to be all on MathXL, so it's probably going to give you the formula. You're not going to have to remember any formulas, so that'll be okay. But this is going to be our compound interest formula, okay? They're going to give us 2 different ones. So the only thing in this we need to be able to do is we need to make sure that we can understand what the variables are. So A is going to be the amount in the account. P is going to be our principal. Which is our original investment. What else we got in there? We got an R, which is our interest rate as a decimal. N, number of compounds. So let's talk about that real fast. Okay. If it's compounded annually, oops, if I could write annual, that means we're going to do 1 time a year. Not going to see that, but just to go over it. Again, if I could spell tonight, semi-annual, that's going to give me a 2. Quarterly, oh my gosh, 4. Monthly, it's going to be 12. All right, so those are the values of N that we need to make sure that we're grasping and getting. And then lastly, T stands for time in years. Okay. So in number 1, unfortunately, again, is another problem with 4 parts. But here we go. In part A, it says you find the accumulated value of an investment of $10,000. So we know we are going to invest $10,000, and it is compounded semi-annually. So before we get that, let's jump back up to the other one. This one has the same exact variables in it, except we have E. E is a constant, exactly like pi is. We know pi is 3.14. Okay, it is some decimal, just like that. We also can tell what E is. E is going to be a constant. Okay, and that constant is going to be, so, just like, so I'll write this down. Pi is 3.14, blah, 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 blah. E is going to be 2.718, blah, 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 blah. Again, we don't have to worry about rounding that off. My calculator has E in it. Again, we'll throw my calculator in here. I better pull this up so we can make sure we see that. I'll raise this up so we can see it. Probably out of focus, but we have a natural logarithm there, okay? And then, it's a little more in focus. There's my e to the x, okay? So this is the e that we're using, okay? There is an e over here next to your divide sign that we could use, but we usually don't. Anyway, where was I? So we know, since we're compounding, this is continuously. Okay, so we know that's there. But this one's not. The part A is compounded semi-annually, so I know n is going to be equal to, but it's all going to go. I'm trying to find the amount in the account when I invest $10,000, so use some of that graduation money. 1 plus my interest rate, it said, what does it tell me my interest rate is? 5.5%. So we have to remember that interest rate goes in as a decimal, so 0.055. N is the number of compounds, so it said semi-annually, we're going to put a 2. And then we're going to have that n again, which is a 2, times the number of years. And it said it wants to do it for 4 years. And it said round to the nearest cent. So in part, the 4.1 here, this is a complete calculator exercise. Okay? So we'll blow this up just a little bit so we can see, not that we need to, I don't know what I'm trying to do. So we can type this in that I covered it up and can't see it. Let's try again. So we have $10,000 that we're going to invest. This is going to be 1 plus 0.055 divided by 2. We're going to drop my caret key in there, and then we can write up here to 2 times 4. Now, depending on your calculator operating system, whether you need to have all that in there, you probably don't need the parentheses up here in the exponent, but we just wanted to have that. So we're going to hit enter. We're going to round that to the nearest cent. So I know this is going to be $12,423.81. Okay, not that you could even see that on my screen, but there we go. Okay, now that I've blown this up too big, we'll go the other way. All right, and there we have that. Okay, part B is the same exact thing, except now it wants us to compound it quarterly. So the only difference here is, for part B, is we're going to change this to a 4, and we're going to change this to a 4. And so in reality, we can just go back to our calculator. And again, I got to jump between screens here so I can kind of see what you're seeing. So in our calculator, if you hit second up here in the corner next to my thumb and enter, that brings up what you just got done doing. Oh my gosh, that is so horrible. Okay, so there it is. So I can just arrow back and I can change this 2 to become a 4, and I can arrow back some more and change this 2 to be a 4, and I hit enter, and there it is. So again, typically when we start compounding more often, you're making money on money that you compounded previously. So the more times you can compound, the better off it is, and that holds true there, because this went to now $12,442.11. Okay, so we can see just by increasing my compounds, I gain over 4 years, I gained myself almost 20 bucks. Okay, which doesn't seem like tons, but it actually is. What's the next one? Compounded monthly and then compounded continuously. Okay, so compounded monthly, again, we're just going to go back to our calculator. We're going to change it to a 12 and change this one to a 12. So again, I'm going to go back to my calculator, which I have no idea if you can see because I'm in the wrong screen. There we go. All right, so if I turn this off, that is not helpful. All right, so we're going to hold this in such an angle so you can actually see something. My gosh, why is this so hard? So we're going to hit second, and we're going to hit enter again. So again, all that did was bring up my previous. Now this one gets a little bit more tricky, just because your calculator is automatically in type over mode. We need to change it to insert mode. So I'm going to hit second, and I'm going to hit the above delete. It says INS for insert. So now we can see my cursor changed. Not a solid block anymore, and I'm going to hit 12. So now it inserted the 12 instead of typing over the 4. Okay, and then I'm going to hit the delete button, which deletes the 4, and it puts me back into type over mode. And I'm going to come out here. Same thing. I'm going to go into insert mode. I'm going to put a 12 in there, and I'm going to delete the 4. And so now we see we have 12,454.51. All right, so now we've gained $31 in interest, okay, by compounding it monthly over a 4-year time, okay? And then lastly, that was part C. We got to do part D, which is the continuous part. So now we need to jump into a different equation. We're going to do 10,000 E to the 0.055 times T, which is 4 years. So again, this is all based on a base of E, and we'll get into that later on as far as its base of a logarithm and some fun stuff like that. But E is what we use a lot in banking for exponential functions. Anyway, going back to your calculator, again, this is straightforward. Just drop in our calculator, and away we go. We have 10,000. If you look above the natural log, you can't see my thumb. If you look right above your natural log button down here, you're going to have an E to the certain power. So we're going to hit Shift and natural log. That's going to be E to the, and we're taking 0.055 times, what do we say? 4. And again, the power of compounding interest, just by changing to something that compounded continuously, now it's 12,460.77. Okay? So again, the more times we can compound something, the more money we are going to make. Okay. If we look at 6, we have $12,000 to invest. Suppose you have $12,000 to invest. Which of the two rates would yield the larger amount in 5 years? Hold on. We can make my life easier. I forget that I have 2 screens. So we can go, there we go. Now we're cooking with gas. Okay, in 6, suppose you have $12,000 to invest. Which of the two rates would yield the larger amount in 5 years? Would you want to invest $10,000 quarterly or 9.88% compounded continuously? So the first one, again, is going to be compounded quarterly. So that means that the amount in the account is going to be $12,000. We have an interest rate of 10%. We're going to compound it quarterly for 5 years. And basically they want us to compare that to what if I took the same money and I was able to put it into an account that compounded continuously, except this time at a reduced rate of 0.0988 for that same 5 years. Which one am I going to make more money in? And again, this is a straight up, just a drop it into your calculator. I'm not going to burden you with seeing me do the keystrokes. We're just going to type it in as we see it. And so this is going to give us 19,663.39, which rounds up to a 40. And if we go the other way, we have 12,000. And that's going to be 0.0988 times 5. It's going to be 19,666.30. So we can see that if we can compound it continuously, even though it's at a lesser rate, we're going to have more money in the end. Okay. And finally, I don't care. It's exactly the same way. It gives us a formula to work with. We're just going to drop those values into the formula. I'm not going to do number 7 just because it worked like the last 2. It's just working with a different formula. So I'm going to wrap this one up. We're going to call it good. That was 30 minutes. Wow. Okay.